Okay. So this is an example of a binomial experiment. A binomial experiment, I want to tell you that it's this idea of either this or that. Please don't get that confused with the union, because it's not really that, right? The union is this or that. We could go in. It's not that big of a deal. This is this idea of you have path 1 or path 2, and that is it. You only have 2 paths, binomial 2, right? So it's this idea of they call it like dichotomous testing. So there's a split dichotomous. It could be, heads versus tails. So when we're talking about flipping a coin, that's a binomial experiment. Win versus lose. Success versus failure. And statistics like to use this like it's a success or it's a failure. And I know that we have like some pretty negative connotations with some of those words, but it's just a failure is just that we don't, the experiment is not satisfied in the way that we're looking at it. Maybe not the way that we want it to be, but want is not a thing that really should be taken into consideration when you're talking about statistics. We have an experiment that we're looking at and a trial that we're using to test that. And there's either a success or there's a failure, and that's it. Each of the trials that happen with binomial experiments are independent, right? A flipping of a coin, one flipping of a coin does not rely on the other one. The boxes of cereal, right? You have either a success of getting the figure or a failure of not getting the figure. But getting a figure in one does not tell you like, oh, well, if you get a figure in your first box, in the second box, there's a possibility of this and a different probability occurring. They're completely independent. They don't have any sway on each other's results. And so that's also something to note with binomial experiments is it's always independent. Trials. Okay, so your binomial probability distribution, you have a whole calculator that deals with combinations, you have a whole function that deals with combinations. The reason why combinations is because you might notice that this sort of idea of how many times can you organize 2 F's and 3 N's, you have to deal with combinatorics, which I think you learned with QWERTY. So you don't have to be an expert on it. If you just kind of vaguely remember this idea of things moving around and how many different ways can you move this situation around, it is derived or connected to this idea of combinations. And that's what the formula is. If you look in your textbook gives you a formula. However, your calculator also calculates it for you. Heads up, TI 84s. I will only be giving TI Nspire instructions. I highly recommend going on to YouTube or going on to Cognity. They will have the TI 84 descriptions of how to go calculate this. You cannot do any of the calculations for the rest of this class without knowing how to do it. So when I first explain it, maybe kind of pause the video quickly. It'll take 2 minutes. Go to YouTube and look it up. Okay, binomial probability distribution. How we calculate it. You can see I was doing these calculations earlier. First, we need to go to menu, write these steps down, because I'm sure you will forget. This is a whole new part of our calculator we haven't looked at before. And we want to go to probability, which is 5. And then we want to go to, hopefully you can figure it out, distributions, because we're talking about a distribution here. And then right down here, there's even more stuff down there that we will be using. But what we're looking for right now is binomial PDF, probability distribution function, PDF. So that's choice A. So you can always just type in these numbers, right? You can hit menu 5, 5A, and it will result in this situation. And that's binomial PDF. Once you hit enter on that, you've got a bunch of different things that it's asking for. So number of trials, N. Let's go ahead and calculate what we did above. N is our number of trials. Our number of trials in the previous problem was 5. We had 5 separate boxes we were looking at, so there's 5 separate instances. 1, 2, 3, 4, 5. We were always trying to fill 5 slots with this idea of the probability that occurs within them. So above, our answer would have been calculated using a calculator by putting 5 in for N. The probability of success is the probability of the thing that we are looking at. So in this case, it said, our question was, what's the probability of having exactly 2 figures in a box? So our probability is the probability that goes with getting a figure, which is 0.2. If it asks for what's the probability of getting exactly no figures in 2 boxes, you then need to change the probability. So it needs to go with that question, the probability of the thing that you are looking at. Because sometimes, I guarantee you, I haven't seen it yet, but I guarantee you there's going to be a question out there that they give you the probability of the thing that you're not looking at, and you need to realize that you subtract that from 1 to get the probability that you are looking at. So just be aware of that. So your next one, P, is the probability of success. Again, success just means of the thing that you're looking at. It could be a bad thing. It doesn't matter. Your X value here, it says optional. What it is the number of times you want this outcome. So above, the number of times that you wanted that outcome were 2. You wanted the probability of getting a figure 2 times. If you do it without putting in that number, if you don't put in a number here, because it does say optional, it gives you the entire probability distribution. So it first gives you a set of probabilities. It's going to be a massive list. And it'll give you the probability of getting 0, the probability of getting 1, the probability of getting 2, probability of getting 3. So it gives you your entire probability distribution for binomial probabilities. So that's kind of handy if you needed all of the probabilities instead of just typing in 0, 1, 2, you could just get the list. So if I just type in 2 here, because we want the probability that that there were 2 figures, we press enter, and we get 0.2048, which, hey, is the answer we got above. So that's just really quickly how you use your TI Nspire. If you have a TI 84, please write out your list of calculator instructions. So that way, like, your tutor can help you, you can help you. It's good to write out the instructions. And then here's the values that you need to look for. Let's try it again, and we're going to practice it again. A computer shop orders its laptops from a supplier, which has a rate of defective items of 10%. The shop usually takes a sample of 10 laptops and checks them for defects. If they find 2 laptops are defective, they return the shipment. What is the probability that the random sample will contain 2 defective computers? So as we're getting further into our year, into our 2 years, we need to make sure that we're being aware of the types of problems that we're reading and how to know which strategy to use. Because now you might sit here and try and apply what we learned in our probability unit last time. And that's not what you need to be applying here. You should be using your binomial distribution. And so how we know that this is a binomial distribution is that it's dealing with probability, and it's either a success or a failure. Either it's defective or it's not defective. There's only 2 options here. And that you're doing this over and over and over and over. So there should be that idea of either this or that over and over and over. And that's how you know that this is a binomial distribution. And so as a result, you can use your calculator. So I want you to tell me what we plug in for n in our calculator, what we plug in for P in their calculator, and what we plug in for the X value in our calculator. So remember that N is the number of trials. So it's the number of times that we're looking at this situation. The sample included 10 laptops. So we're checking this 10 separate times, which means our number of trials is 10. If we were to list it out like we did in example 1C, we would have 10 slots of either defective or not defective listed all out and having to move them all around. P is your probability of success. Success in this case is the thing that we are looking at. And since our question says, what is the probability that their random sample will contain 2 defective computers, we need to look at the probability of it being defective. It tells us the probability of it being defective is 10%. We need to write that down as a decimal, not as a whole number percent. The X value is how many times we want this outcome to look to occur. So what is the probability that their random sample will contain 2 defective computers? So realize I've just read you the same sentence like 3 separate times, looking for 3 different things. So this is a strategy when you're trying to figure out what you're doing, is focus on one variable at a time. Write down, I knew that I needed this as a, sort of an idea of writing down my formula. I knew that I needed this in order to plug it into my calculator. So first I just focused on N. Okay, rescour the instructions. How do I find N? And then P, I need to make sure I find the probability of exactly the thing that I'm looking for. So I had to reread the question that's asking me something and then go back and find it above. So focusing on one thing at a time is going to be really helpful for a strategy to make sure that you understand. So your X value is 2. We're looking for 2 defective computers. I'm going to go back to my probability menu 5A, 10, 0.1, 10, 0.1, and then 2. And the answer is 0.194. Let me write this out in official terms. So you're still getting used to that. The probability that the number of outcomes that we're looking for is 2 is 0.194. All right, back page.